Hello and welcome to yet another video. Today we have an Asrock board, a B450 Pro4. And I think I've fixed one of these before, but it wasn't in a video. And I really don't remember what I fixed back in the day on it. And hopefully this will be an actual video, because I've just started two different mainboard videos. One where I didn't have a fitting CPU and another one where the board was just working and I had to toss those videos out. So hopefully we actually can fix something on this board here and actually get something out of it. So I have no idea what is wrong with this board. This came to me without the IO shield, without anything, no packaging, just like the bare mainboard itself. It came off of eBay, and I don't know what is wrong with it, what the behavior of this board is. So we probably should start with taking some measurements, but I think we're going to go instantly over into just plugging a CPU into here, and let's see how this board behaves. So the passive power consumption looks very healthy. Let's now see reaction to the power button. And we do not have a reaction to the power button. Great. So you know what that means. How we're going to start as soon as we don't have a reaction to power button. Let's get the multimeter onto here. So let's see, do we have voltage? Yes, we do have voltage on the power button. So that isn't the problem. Let's see, the BIOS battery, 2.1. That is way too low. Okay, so the BIOS battery could be a problem. Let's reset the BIOS. Let's short the clear CMOS header on here. So the BIOS has been reset, and let's see if this had any difference, and it didn't. So still no reaction to the power button, but we still have the 3.3 volts. I would now go around the SIO area and see for any damage there, because this is the first thing that I would expect as soon as we don't have a reaction to the power button. And after that, looking at the PCH also. Let's see if we can quickly find the PCH voltage maybe. Okay, this isn't, so I cannot find the PCH voltage right now. So PCH voltage might also be a thing that we have to take a look at. But let's first look at the area around the SIO if we see anything damaged there under the microscope. So let's have a look at this area. What is that? Oh, I can already see the damage. Oh yeah, I think I found it. So I was just looking at this here, but this is nothing. But I found the damage. Look right there. This is probably a missing resistor right here. Yup, that is probably it already. Just like I thought, damage around the SIO when we don't have a startup. So I'm pretty sure this is supposed to be a resistor here. So let me see if I have a board view for this and if we can figure out what kind of resistor is supposed to be there. So now in the board view, let's go into our SIO area, and I'm pretty sure it was this resistor. SKTOC. No idea what this is supposed to be, but it comes from the CPU. So this does look very important. Where does this come from? This is connection between the SIO and the CPU directly. Okay. And this has to do with the battery. So yeah, this really looks like this is what we need. And this is a 0 ohm resistor that is here. As you can see, 0 ohms. Yeah. So let's just get a 0 ohm resistor. And let's try this. So let's now prepare our area. What we do is we apply Flux. And now we clean up the area. So we clean up the two solder pads that we need with some leaded solder. We don't want them to bridge. And now what we do is we get our 0 ohm resistor in here. There it is. 0 ohm resistor. Let's get this into place. So we need it right there. And what we do now is I grab the resistor and I tack on one side just like that. That one side of it is connected. And now I go over to hot air. I just noticed my temperature was way too low. That's why it was melting so badly. Now it's properly on. And let's now get hot air into here. And let's now reflow this. So this will be in its place. Right now. Now it's properly soldered in there. And now let's clean it up already. Because Flux is the easiest to take off when it's hot. And still in a state like this. So our resistor is now in place. And let's now go into the overview again. And let's now try all of this again. So let's see, we have a little bit higher power consumption. This is already a very good sign. And let's press the power button. And there's reaction to the power button, just like we expected now. The power consumption looks very good. Let's see if we can get a post screen into here. I see it resetting multiple times on the PCIe tester. And we already had almost 4 amps right there. The BIOS has been reset because we took the battery out and the battery was very low. And there we have a post screen. Very, very nice. So yet another 0 ohm resistor that was knocked off. Let me get a battery into here and let me get this board fully built up with the graphics card, with the CPU, and let's get into testing. So the board is now running. We have 4 DIMMs of RAM. We have a GPU in here. We have M.2 connected there. This is the OS that is running. We have the CPU in here. And currently I'm running Linpack. As you can see, the amperage is very high. We have about 8 amps. As you can see in the peaks right there, almost 9 amps. And it shut off, I think. No, it just cannot show 10 amps. So it draws a lot of amps currently. You can also see that by the voltage actually dropping. So yeah, this is actually testing it pretty hard. And let's see. And I'm pretty sure that it will be stable and that it will pass all of the tests. Because all we had was a startup issue. But I will get you back in here as soon as that test has finished. So Linpack has also passed without any problems. And I'm pretty sure we've come to the end of this repair with that. And yet again, shows very well. As soon as you have problem with startup, first 2 things that you need to have a look at is the PCH and its voltages, resistances, and also the SIO with its voltages and resistances, and missing components. And sometimes there's a lot of other things that can be like around the CPU circuit. There could also be stuff, but like this was very low hanging fruit, just a normal 0 ohm resistor that was missing. Really easy to find, to replace. So, hope you still learned something, hope you enjoyed the video. Thank you very much for watching and goodbye.